we have here, in a survey of university students, 64 has taken mathematics course, 94 chemistry, 58 physics, 28 math and physics, 26 math and chemistry, 22 chemistry and physics, 14 all three. Does anywhere in here say only? No, so we're going to have to subtract. If you didn't subtract, you're going to have problems, right? Because only means no subtraction. But if it doesn't say only, you will have to subtract. So you can do them in any order you want. I'm going to do chem, math, physics, just because I felt like it. And I don't short form. And I put a box around it, even though there's no one in the box. So, 14 took all three, goes in the middle. Then we need 22 that are in chem and physics. Chem and physics eyeball is here. And I need to have 22. I already have 14. So how many are in chem and physics only? Rhymes with schmate. 8. Good job. All right. 26 had taken math and chemistry. 26. So it'd be 12, because it can be 26 minus 14. Then 26 math and chemistry, we did that. 28 math and physics. So in the math and physics eyeball, I need to have 28. I already have 14. So how many are in math and physics only? Now 58 have to take physics. So in the physics circle, I need to have 58. I already have 36. So how many are in physics only? What? How many is it? 22. I heard 52 and I was like, there's no way. Oh. In my head, I heard 52. So I was like, what did you say? I was like, it has to total to 58. We got problems. Okay. And then chemistry needs to have 94. And there's already 34. So it'd be 60. And then math has to have 64, so it has how many? 24. So math only, 24. Now watch this. Math only equals 24. If I do this, if I put the squiggly brackets around it, which so many of you do, it's wrong. Because that means that the actual number 24 is in math only. Is the number 24 in math only? No, the total number of people is 24, correct? So this is actually wrong. This would mean that the number 24 was a number in math only, which is not true. So you don't do the squiggly brackets unless you have like numbers listed, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we put them in their own spots with evens and odds, let's say, and we list 1, 3, 5, 7, 9, we put those in squiggly brackets. That would be if it was an element in the circles, right? But if it's the total number of people, you don't put squiggly brackets, because that means the setup. Okay. Next one says a computer access code consists of 3 different digits that screams can't repeat. 3 different digits that can't repeat, and 1 letter A, B, C, or D. So there's no restrictions on the back one. Here it says the first digit cannot be a 0. So it can be 1 to 9, which is 9. Now it needs to be different digits. We agree? So that means I can't repeat. So I'm going to have to hold 1. So I do 1 to 8, which is 8. Is it 8 here? No, what can I bring back? 0. It was never used. So it's actually 9. Then say I hold the 0. It'd be 1 to 8, which is 8. And then 4. What's 9 times 9 times 8 times 4? 2590?
2592.
92? I was like, I don't remember it being that number last time. Okay. This one here says the special menu at a fast food restaurant allows you to choose 1 sandwich, 1 drink, 1 cookie. 1 sandwich, 1 drink, 1 cookie. It has to be 1 of each or I can't use the fundamental accounting principle, correct? Because the blank means I'm putting 1 in there. So I'm doing 1 sandwich and 1 drink and 1 cookie. If I could pick 2 cookies, I can't do the blanks. I have to do something else, which I don't know how to do, so right now you probably figure out that you probably have to do the blanks, because I haven't taught you the other method. But if you pick more than one of each, you can't do the blanks. Okay? So, how many sandwiches are there? 5. Drinks?
3.
Cookies?
2.
Why am I multiplying? Because it's and. I need a sandwich and a drink and a cookie. And that gets me
30.
30. Left to right, only fill in the number of boxes you need. Okay? And we're going to flip over. So we need to solve a rational. These aren't going away. They're going to stay for life because they're on your diploma, right? They're going to be on cumulatives. So we're going to keep going. Eventually, hopefully, if they haven't clicked yet, they will click. Eventually. That's my hope. So here I have a monomial in the denominator. Here I have a binomial, sorry. And here I have a monomial. Binomial and a monomial. Can I make a binomial be a monomial and monomial be a binomial? No. That just sounds really confusing. You can't. So you have to multiply them by each other. So we're going to get 3 over 3x plus 2 times 5x. Do we distribute our denominators? No, unless they're monomials. And then we get 6 times 3x plus 2 over 5x times 3x plus 2. So I'm going to get 15x over 5x 3x plus 2, because I can put them in any order because it's a commutative property when we multiply. So I can list it first. Equals 18x plus 12 over 5x bracket 3x plus 2. Now, if the denominator's equal, I can set the numerators equal, correct? But that means I'm going to be getting rid of my denominators, aren't I? So what do I have to state first before I get rid of denominators? Non-permissible values. So 5x, x just can't equal 0. And then 3x plus 2, it's negative 2/3. So these are important, because if my answer is one of those, it's out. Right? If my answer is one of those, it's out. So if this denominator equals this denominator, I can say that 15x equals 18x plus 12. When on one side you have an x and on the other side you have an x, your goal is to get the x's together. So I'm going to subtract the 18x and move it over. So I get negative 3x equals 12. Trading over here some space. Divide by negative 3, and what does x equal?
Negative 4.
Negative 4. And then I say x can't equal 0 and negative 2/3. Is my answer the non-permissible value? No. If it was, I would circle it, put a line through it, and say extraneous, right? If it was. Number 5 is monomials times monomials. So when it's multiplication, we can draw a whole line. Number 5. We're going to start canceling. Before we start canceling, we want to state these are all monomials, so they're all in their own brackets, right? Every single one of them. This looks ridiculous, so I'm going to write it as negative 3x y squared z 4 y z cubed, and technically times 20x squared y cubed z over 9x4 y. Okay. So anything that matches on the top and the bottom can cancel off, correct? And it's a 1-for-1 deal. So I have on the top an x and an x squared, so that's 3 x's, right? And then on the bottom I have 4 x's. So I can cross these 3 x's off with 3 of these, and I'm left with 1x. On the top I have y squared and y cubed, which is y to the 5. I have 5 y's. On the bottom I have a y and a y, so I have 2 y's. So I can take these 2 y's off for these 2 y's. On the top I have a z and a z, which is z squared, and on the bottom I have a z cubed. So these z's can cancel this off and get a 1. And then you could cancel the numbers as well. You can go 4 and 20 is 1 and 5, 3 and 9 is 1 and 3, or you can just go negative 60 y cubed over 36 z xz, and then take a 12 out of each of these. So this is negative 5 and this is 3. If you reduced it beforehand and you get negative 5 over 3, do I care? No, I care that you have the right answer. I don't care how you'd simplify it to get there, right? So we're going to get negative 5y cubed over 3xz, xyz, can't equal 0. Because whenever you have monomials, your variables are just not equal to 0. The next one people find a little more difficult than it actually is. Once we go through it, you'll be like, oh, that's not bad. So it says, how many odd 2-digit positive integers? It just means that they can't be negative, right? So what I could have just said is natural numbers, but I did positive integers. So 2-digit odd means the back number has to be 1, 3, 5, 7, or 9. And if it's a digit number, the front can't be 0. And you would normally go 9 and 5 and give me 45, correct? But I said greater than 20. Greater than 20. So is 19 greater than 20? No. Is 23 greater than 20? 23? Yeah. Is 30 greater than 20? 40 greater than 20? 50, 60, 70? 10 greater than 20? No. So what was my first digit in order to be greater than 20? 2 or higher, right? So if I put a 1 here, this is what I explained. If I put a 1 here, the options I would have is 11, 13, 15, 17, or 19. Are any of them bigger than 20? No. What if I put a 2 here? 21, 23, 25, 27, or 29. All those are good. What about a 3? 31, 33, 35. Yep. What about a 4? A 5? A 6? A 7? An 8 or a 9? All of these, if I start with this number as my first blank, will be greater than 20. Correct? Does it say anything about not repeating? Nope. So we can repeat. So here's my 5, and here's 9, 8, which gets me 40. Now this one I've given you is a 3-digit, a 4-digit, a 5-digit, and guess what? I now give you a 6. If you haven't noticed there's a pattern, I'm going to keep repeating it. So how many 6-digit? 1, 2, 3, 4, 5, 6. 6-digit means this can't be a 0, because then it would be a 5-digit. How many 6-digit odd numbers? 1, 3, 5, 7, 9 can be formed if no digit can be repeated. The moment I can't repeat, what do I have to do? Yeah, take one off. So you can box it, you could circle it, you could highlight it, whatever you want. You have to make one stay, right? So I go to the very back, I have 5 options, and then I'm going to make the 9 stay. You could make 1, 3, 5, or 7 stay, it doesn't matter. I just can't list 9 now here. So I have 1 to 8, which is 8 options. Now I'm going to pretend I keep the 8. So then I have 1 to 7. And I put a 7? No, what do I put? 8, why? Because a 0 can come back. Hold the 8 here, then I have 1 to 7, which is 7, then 6, then 5. Is it 67,200? For some reason that's sticking in my head. Is that what it is? I did not do that math. We did it last class, and for some reason it stayed. Yes, sir. There's no way that was happening in my brain. I'd like to pretend it did. It did not. So when you're done that, can you guys flip to your notes, page 5. We're going to look at homework number 1. We're going to start looking through the homework. So there's the word script at the top, number 3, number 4, but then we're going to go to homework questions. So if you can visualize whatever the heck it's asking, it will make it a lot easier for you. So here it says, how many ways are there of arranging 6 different math textbooks. So example, I have 2 sitting here. I have a 12 and an 11, right? They're different. So if I go like this, or I go like this, has the order changed? If I flop them, can you see the difference? Is it obvious? Yes, because they're different textbooks. Do you agree? So say I have 6. Okay, so I have 6 different math textbooks. I got myself Principles of Math, Pre-Calc 12, 11, some weird something. 30 has some key, Calculus with a hummingbird, Calculus was a red textbook from 1980, blah, blah, blah. This was old. Okay, so. These are funny. So, I take these textbooks. I have 6. We agree? How many spots do you have to put these textbooks in? 6. Miraculous, isn't it? How many options do I have for the first one? 6. And then I do what? Write it down. People tell me I don't, but I have to, right? Okay? How many do I have for the next blank? 5. Okay, and then what do I do? Put it down. So does it say not replacing? Does it have to say not replacing? No. In order to set 6 textbooks down, can I replace them? No. Okay, just one second. And I'm going to do my next spot. So for those of you who keep putting 6, 6, 6 in every blank, this is what you're doing. I've never put one down yet. I'm just literally lifting textbooks and putting them down. Never leaving one behind, am I? So am I ordering them in a row? No. So just because it doesn't say I can't repeat, I can't repeat. It doesn't say it, but I know I can't because what am I going to have to do? Set one down, correct? Then I have how many options? 5, and I need to set one down. Then what do I have to do? 4, then that one is 3. Of course, the calculus one revolts against standing. 3, 4, 5, 6. Okay, good. So 1, 2, 3, 4, 5, 6. How many do I have options for this one? 6, because I could technically have book 1, book 2, book 3, book 4, these are really tiny, book 5, book 6, couldn't I? And then what do I have to do? Leave a book, don't I? Then I would have 5, then I would have 2, then I take my last one, whatever's in my hand, and I put it down. Now, I need to lay the first book, and the second book, and the third book, and the fourth book, and the fifth book, and the sixth book, don't I? Yes. So, that's 720 because I somehow have that memorized. Childhood memory's gone, but 6 factorial 720 is still there. So, you can go 6 times 5 times 4 times 3 times 2 times 1 in your calculator. Or, we need to know that if we can rocket count means we start at a number and go down to 1 and can say blast off. Okay? If we can do that, we can use the factorial symbol. So, what the heck's that? 6 times 5 times 4 times 3 times 2 times 1, blast off. I can do that, correct? If I can do that, I can actually type into my calculator 6 factorial. Now, it looks like I'm screaming 6, because it looks like an exclamation point. But in math, it doesn't mean you're screaming 6. It means 6 factorial. Now, if I had like 20, and I went 20 times 19 times 18 times 17 times 16 times 4 times 3 times 2 times 1, if I did all of those, I could go 20 factorial instead of typing in 20 times 19 times 18 times 17 times 16. Okay? Now, where the heck is that little button? Well, sometimes they literally just leave the answer be 6 factorial. They don't even give you an answer. They don't make you find the answer. But if you do, you go 6, so press the 6 button. I don't feel like picking up my actual calculator here. 6, and then you press math. And why do we press 6? Because we have a 6. Crazy. So we have 6, and then math, and then we arrow over to the left to probability, PRB. And then do you see that little symbol anywhere?
Yes.
Yeah. You can go to the right 3, or you can arrow left once. If you arrow left once, it goes to probability, or arrow right 3 times, or 4. And then you pick number 4, which is the factorial symbol, enter. can either arrow left probability or right a few times probability. You just get the probability. And then number 4. Enter. Did everyone get 720? Okay. So for this unit, that's where we're going to go all the time. We're going to go math, arrow over to probability, and everything we need is either 2, 3, or 4. 2 is perms, 3 is coms, 4 is factorial symbol. So the NPR and the NCR on your calculator right below the factorial, we'll be using those 3. Just not today. Okay. Number 2. With the new renovations completed at Holy Trinity Academy, there will be 7 entrances. So there's 7 entrances you could take it to get into the school, okay? In how many different ways can a student come in for math tutorials if they have to enter and exit through any entrance? Okay, so what are they doing? They are entering and they are exiting. How many blanks do I have? 2. They have an enter blank and they have a exit blank, do they not? They don't have 7. They're not like... And then I'm back at math. You don't need to do all 7. You guys will put 7 blanks every single time. You only need 7 as if they were entering, exiting, you know, like they were kind of crazy. We don't want that. We want them to enter. We want them to exit. They're doing 2 things, correct? So 1 would be enter blank. And 1 will be exit. Now, do we multiply or add? Do we have to enter and exit, or could we enter or exit? It's kind of and, because if you had to just or exit, you had to be inside something weird. So and, so we multiply. How many ways do I have to enter? 7. Do I have to leave 1 way behind? No, because it says I can enter and exit through any entrance. So could I just like enter through the downstairs and then exit through the downstairs? So I still would have 7 options, wouldn't I? So 7 and 7, which is 49. The next one, we need to enter the school and exit through a different entrance. So I can enter however the heck I want, but I need to exit through a different one. How many options do I have for entering? 7. Then how many options do I have for exiting? 6. So 42. Enter and exit through the same entrance. Nope. Yep. It's going to be, how many do I have options do I have to enter? No. 7. But whatever one I enter through, I have to exit through, so 1. Number 3 I haven't seen on a test, but I give it just in case, because just in case you get something like this. So it says the score at the end of the second period of a hockey game is Flames 6, Oilers 3. Remember, game started 0-0. That's me reminding you, because if I don't remind you, people get this wrong. Matthew Tkachuk was trying to determine how many different possibilities there are for the score at the end of the first period. Can you score all those goals and then stay the same till the second period? Could you technically get 6-3 by the end of the first, and then by the end of the second be 6-3 still? Yeah, very boring second period. That's what that is. Okay? So at the end of the first period, they could still be 6-3, right? That's an option. They could be 6-1. They could be 6-2. They could be 6-0, and then in the second period, the Oilers rocked it, right? I know, hard to believe, but could happen. And so he used the fundamental counting principle and multiplied 6 by 3 and got 18. So he did Flames here, Oilers, 6 times 3 and got 18. But he's wrong. Let's list his options. So in the Flames and the Oilers, what was his options for under the Flames? What were the scores he could have? 0 to 6, which is actually 7. And the Oilers, what could they have for options? 0 to 3, which is actually 4. So it's 28. You guys try number 4. They are not the same answer. So if they're the same answer, think in your head something's wrong. Try number 4, A and B. So We have in each of the students, if holy, come on, Lepp, that's an F. If each of the students in a class of 30 students is capable of winning any of the class prizes, how many ways are there of awarding a first, second, and third? So first prize and second and third. So, Tyler, how many would be in the first prize?
30.
30, then what? How many could win second? Yeah. 29. Why did it go down by 1? Because someone won first and they can't win second and third as well. That's unfair. And then 28. So how much would this be? 24,360. Then we have, I told you that A and B cannot be the same. That was my hint to you. So now we have a math prize and a chemistry prize and a physics prize. Now people will tell me 30, 29, 28. Let's think about the valedictorian. Could the valedictorian win the math prize? Does that mean that they're out then on the chem and the physics? Nope, they could clean sweep it all. It's just sad. Just sad. It was just me. I would have totally cleaned. No, I wouldn't have. I would not have clean sweep them all. So, math prize, chemistry prize, physics prize. So your math would be how many? 30 options. And how many possible could win chemistry?
30.
And then how many in physics? 30. So you have 30 cubed, which is 27,000. Because 3 cubed is 27, and 0 cubed is 3 zeros. Okay? Then we're going to flip over. Okay. So we have 3-digit numbers. What does that mean? Pardon? Yeah, so we need how many blanks? 3. And what does 3-digit number mean? The first one can't be a?
0.
And did I even have an option of a 0? No, so it would have saved me, if anything, right? So we have 3-digit numbers formed by 2, 3, 5, 6, 7, 9. We agree? So those are my options. 2, 3, 5, 6, 7, and 9. Yeah? Okay. Now, if repetitions are not permitted, that means I can't repeat the numbers, correct? I have to have three blanks, and that's it. How many 3-digit numbers can be formed? I know the first blank can't be a 0. Luckily, I don't have that option. So what do I have? I have 2, 3, 5, 6, 7, and 9. How many options is that? 6. But what do I have to do now? Hold one, because it says repetitions aren't allowed, right? Could I hold any of them? Yeah, I could hold 7, I could hold 3, 5, 6, 9. I'm lazy, so I always pick the outside one, either 2 or the 9. It's just the way I roll. So 3, 5, 6, 7, and 9 for the option for this one, so 5. And then say I hold the 9, I would have 3, 5, 6, 7, which is 4. And then 30 times 4 is 100 and? Rhymes with schmenty. 100 and? 20.
What?
Schmenty. 20.
Oh.
You know, schmenty, the normal 20 rhyming word. Okay, do you see these other ones here? Less than 400. What does that tell me? Must be less than 400. So what does my first digit have to be? Of the options up there, 2, 3, 5, 6, 7, and 9. If I need to be less than 400, what does my first digit have to be? 2 or a 3, because anything higher than that will make me have a number larger than 400, right? Even means it has to end in a even number. Odd means it has to end in a odd. Multiples of 5 means it has to end in a 5 or a 0. The only problem is we only have the option of 5. So we still only have these digits to use, and these still can't repeat. Okay? So I still want Three-digit numbers that can't repeat. 1 is less than 400, 2 is even, 3 is odd, 4 is multiples of 5. So can't repeat, so I'm going to have to box them, keep a number, and still 3 digits. Okay? You try them out. 1, 2, 3, 4. Go. So we need less than 400, and we need 3 digits, and we need not repeat. So this will be the option of 2 and 3, which is how many options? 2. So we list the options below the number of options above. Then I pretend to keep one. I'm going to keep the 3. So then I have 2, 5, 6, 7, 9, which is 5 options. Keep one. 2, 5, 6, 7, which is 4. So you should get 40. Now, even and odd usually result in the exact same amount of numbers, right? Like if I go 1, 3, 5, 7, 9 at the back, or I go 0, 2, 4, 6, 8 at the back, I still have 5 options. So odds and evens usually result in the same thing. However, when you give a restricted amount of numbers, they're not going to result in the same thing. So even, 1, 2, 3, 4, I have the options of what back here? 2 and 6. So I only have 2 even options and more odds, correct? So I won't get the same amount. So then I have to not repeat. Why do I have 4 blanks? Pretend that's not there. Looks like a hand. Give me a 5. Okay. 6. And then I would have 2, 3, 5, 7, 9, which is 5. Then 2, 3, 5, 7, which is 4. And I get 40. Okay, then odd, the difference is I have at the back, I don't remember what numbers I have anymore, 3, 5, 7, 9, which is 4 options. And then at the front, I have everything but 9. So 2, 3, 5, 6, 7, 5 options. Trying to keep the 7. I have 2, 3, 5, 6, which is 4. So I get 20 times 4, which is 80. And then multiples of 5, the last number has to be a 5, which is only one option, then I keep it. Then I have 2, 3, 6, 7, 9, 5 options. Keep the 9, 2, 3, 6, 7, 4, and I get 20. Then we're going over the last one, which is the word shipwreck. So this one, if you look up here, this one up here, I gave you 2, 3, 5, 6, 7, and 9. I gave you 1, 2, 1, 3, 1, 5, 1, 6, 1, 7, 1, 9. We agree? Shipwreck is the exact same. I'm giving you 1 S, 1 H, 1 I, 1 P, 1 R, 1 W, 1 R, 1 E, 1 C, 1 K. Right? One of each. Can I repeat them? No, and in this case I can't repeat them because I literally have 1 S, 1 H, 1 I, 1 P. So if I put a P down, do I have that option still? No, I can't. So whenever it's a word, it does not repeat. Without saying does not repeat, you literally can't. Okay? So here it says determine the number of 4-letter words. You need to make sure you read. Sometimes you're arranging the whole word shipwreck. Sometimes you're arranging 4 letters. Sometimes you're arranging 6 letters. Right? So you have to read. 4 letters means how many blanks? 4. Each letter must be used once. They don't even have to say that. They could just say, how many 4-letter words can I make with shipwreck? And you will know that you can't repeat. Okay? So I would have S-H-I-P-W-R-E-C-K. How many options do I have for the first one? 9. And then what am I doing? Keeping one. I'm going to keep the K. So then how many do I have for this one? 8. Then I keep one. And how many do I have for the next one? Then 6. I don't have to show all the letters if it's going down like that. So 72 times 42? What's that?
3,024.
3,024? Now, shipwreck. S-H-P-W-R-C-K are the consonants, and then the vowels are just I and E. So there are 7 consonants, whoops, and 2 vowels. Correct? Always good to write, because often they'll talk about consonants and vowels, so I just write it off to the side to help myself out. 7 consonants, 2 vowels. Now I have contains only consonants, still a 4-letter word. If it contains only consonants, is there anything else about this? No. Can I repeat the letters? No. Can I like write S, 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 S?
No.
No, I have one S, so I literally can't, right? So this one I would have S, H, P, W, R, C, K. How many letters do I have? 7, right? It's because there's 7 consonants, right, Tyler? Yeah. And I hold one there, so how many consonants do I have left? 6, then 5, then 4. And so I should get 42 times 20, which is 840.
Yep.
Number 2 gets people. It has to begin and end with a consonant. So the first blank and the last blank have restrictions, but do the middle ones have any restrictions? No. So if it begins with a consonant, I could have S, H, P, W, R, C, K. I could have 7. Then I hold one, correct? Then the last one I could have S, H, P, W, R, C. Hold the C. I have 6. Then people say 5, 4, and you're wrong. 7, 6, because I still have S, H, P, W, R. That's true. But I also have I and E. So I still actually have 7, because there was no restrictions on vowels. And then 6, which I don't know what that is. What's 7 times 7 times 6 times 6? What's 49 times 30? Begins with a vowel. Begins with a vowel. What do I have to start? Where do I have to start? The very first blank, and what are my options? I or E. Yeah. So I have 2 options for this one, and then I have to hold one. How many do I have left for this blank now? 8. Why? Because the only option I don't have is the E, right? Then I hold one, then what do I have? 7, then I have 6. What's that? How much? 672. What about this one? Begins with a K, ends in a vowel. Where do I have to start? Which blank? I always have to start with restrictions first. First one or the last one. I'm going to start with the first one. But you could have started with the last one, because it needs to be an I or an E, right? They don't overlap. K isn't IE and I isn't K, so it wouldn't matter which one you picked. K is how many options? 1, and then I have to hold it there, right? And the back blank, I have how many? 2, but I'm only holding 1 of them. So how many letters have I stuck down? 2. How many letters do I have left? There was 9 total. I'm stuck down 2, so I have 7. 7 left for here. Then I stick down another one, then 6. 84. And then the last one is contains the letter P. What happens when it contains the letter P? Contains the letter P. It's that trick one with cases. P could be in the first blank, or second blank, or third blank, or fourth blank. So P could be here, or here, or here, or here. So it's 1, 8, 7, 6. Make sure you're putting these dots. Do you see those dots? So many people will come to the test and they'll just have blanks. If you just have blanks without dots, you have the number 1,876. Right? If you don't have multiplication dots in between there, you have the number 1,876. Is that what you're trying to have? No. So you need to have these multiplication symbols, or you're actually not showing them algebra. So you could technically just go 8 times 7 times 6 times 1 times 4, which is, I don't know. 8 times 7 times 6 times 4, 1,344.